How do you verify this or check this in the fastest way possible? Digit sum has 4 rules that we need to understand. The first rule is that you have to sum all digits in a number. So let's say we have a number 3, 4, 5. The digit sum of 3, 4, 5 is 3 plus 4 plus 5 equals 12. The second rule is the digit sum should only be a single digit number. Let's say we have a number 2, 1, 3, 4, and then we need to find the digit sum, which is 2 plus 1 plus 3 plus 4. This is equals to 10. This is not the final digit sum because it is not a single digit number, so you have to find the digit sum of 10, which is 1 plus 0 equals 1. Now 1 is the digit sum of 2, 1, 3, 4. The third rule of digit sum is that we have to ignore the number 9. So let's say we have the number 9, 0, 9. Since we're ignoring all the 9, the digit sum of this number will be 0. The number 4 rule that you have to remember when doing this method is that you also ignore digits that adds up to 9. So let's say we have a number 1, 8, 0, 2. So we know that if we do 1 plus 8 plus 0 plus 2, 1 plus 8 will add up to 9. So we can ignore this number and then just go with 0 and 2. So 0 plus 2 will give 2. Therefore, the digit sum of 1802 is equals to 2. So now that you have the 4 rules of digit sum method and that you have memorized them, you can now verify your calculations. Let's verify whether 145 plus 382 plus 478 is equals to 1005. So first we're gonna start with the ones on the left. So we know that 1 plus 4 plus 5, we will have to do the digit sum of all of this. So let's start by 145. If you do the digit sum of 145, this gives us 1 plus 4 plus 5, which is 10. And this is not the digit sum. The final digit sum is 1 plus 0, which gives us 1. Plus, we have to do 3 plus 8. 3 plus 8 gives us 11. Then we have to do 1 plus 1 because 11 is not the final digit sum. And then plus 2. This gives us 4. Plus 4 plus 7 gives us 11. The final digit sum of 11 is 1 plus 1. And then we put down the 8 plus 8. This gives us 8 plus 1 is 10. This 10, the digit sum of 10 is going to be 1 plus 0, which is 1. Therefore, on the left side, 1 plus 4 plus 1 gives us 6. If you do the right side, 1 plus 0 plus 5, it gives us 6. Therefore, our calculation is right. How do we verify that 776 minus 152 is equals to 624? So first of all, we're gonna verify, or we're gonna find the digit sum of the left side. Here we have 776. The digit sum of 776 is done by doing 7 plus 7 plus 6 minus 1 plus 5 plus 2. Here, 7 plus 7, if you think about it, that is equals to 14. 14 is not the final digit sum. 1 plus 4 gives us 5. Plus 6 gives us 11. And the digit sum of 11 is 1 plus 1 equals 2. Here, 1 plus 5 is equals to 6. Let's put down the 2, and 6 plus 2 is equals to 8. Therefore, 2 minus 8 gives us a negative number, which is minus 6. Like I said before, when it's a negative number, we have to add plus 9. Therefore, minus 6 plus 9 gives us 3. Now let's do the right side. So 6 plus 2 plus 4. 6 plus 2 gives us 8. We put down the 4. This gives us 12. And the digit sum of 12 is 1 plus 2 equals 3. Therefore, the subtraction result here is done correctly. Take note that all that I'm writing down, you will have to think about it mentally, and then you will have to calculate it in your mind. We're just writing it down for visual purposes. Now, let's verify whether 467,532 multiplied by 107,777 is equals to 50,389,196,364. So how do we verify this with the digit sum method? First of all, let's start by doing the digit sum of the left side, which is 4 by 6 plus 7 plus 5 plus 3 plus 2 times 1 plus 0 plus 7 plus 7 plus 7 plus 7. So here we can start by adding 4 plus 6, which gives us 10. But we know that the digit sum of 10 is 1 plus 0, which gives us 1. Put down the 7, and then this gives us 8. Plus 5, this gives us 13. Digit sum of 13 is equals to 1 plus 3, which gives us 4. 4 plus 3 gives us 7, and 7 plus 2 gives us 9. Here, we're gonna do the other number. So we can start by 1 plus 0. We know that it's equals to 1. Plus 7, it's equals to 8. Plus 7 gives us 15. We know that the digit sum of 15 is 6, because 1 plus 5 equals 6. And now, as you can see, we are adding plus 7, which gives us 13. Digit sum of 13 is equals to 4, because 1 plus 3 is equals to 4. Plus 7 gives us 11, and digit sum of 11 is equals to 2. Therefore, 9 times 2 is equals to 18. The final digit sum of 18 is 1 plus 8 gives us 9. Now let's do the right side. So here, as you can see, we have 9s. In our rule, we have to ignore the number 9s when doing the digit sum, so we can ignore it right away. So now you know that 5 plus 0 plus 3 plus 8 plus 1 plus 6 plus 3 plus 6 plus 4 is what you need to do. So 5 plus 0 is equals to 5, plus 3 is equals to 8, plus 8 is equals to 16. Digit sum of 16 is 1 plus 6, which gives us 7, plus 1 gives us 8, plus 6, this gives us 14. The digit sum of 14 is 1 plus 4 equals 5, plus 3 is equals to 8, plus 6 is equals to 14 again. Digit sum of 14, we know it's 5, plus 4 is equals to 9. Therefore, we know that the multiplication here is done correctly. Now, how do you verify 2,308,682,040 divided by 36,524 is equals to 63,210? Same thing here, we're gonna start with the left side. So now I will give you a few minutes to solve it, and then you can play the video once again. So here we have 2 plus 3, which gives us 5, plus 0, which gives us 5 still, plus 8, which gives us 13. The digit sum of 13 is 1 plus 3 equals 4. 4 plus 6 gives us 10, and the digit sum of 10 is 1 plus 0 equals 1. Plus 8 is equals to 9, plus 2 gives us 11, and the digit sum of 11 is 1 plus 1 equals 2. 2 plus 0 is equals to 2. 2 plus 4 is equals to 6. And 6 plus 0 is equals to 6. Now we're going to do the 36,524. So we have here 3 plus 6, which gives us 9, plus 5 gives us, as you can see here, we can ignore 9. Now we only have 5. Plus 2 gives us 7. Plus 4 gives us 11, and 11 gives 1 plus 1 equals 2. Therefore, if you solve this side, 6 divided by 2, this gives us 3. Here now we're going to continue with the right side. We know that 6 plus 3 gives 9, plus 2, we can ignore again. Here, the number 9, we continue with 2, plus 1 gives us 3, and plus 0 still gives us 3. Therefore, we can say that the division here is done correctly. So that's how you do and verify and check your calculation really fast.